Hello students, today we will discuss the assignment number 1 on relation and functions. So this is your first question. If A and B are two sets and A cross B consists of 6 elements, if 3 elements of A cross B are 2, 5, 3, 7, 4, 7, we have to find A cross B. So how can we simplify this? Sir, we know number of elements in A cross B are 6. Okay, and we know number of element in A cross B means number of element in A into number of element in B, and this is equal to what? 6. Yes, number of element in A and B are what? These are the whole numbers. Yes, so here number of elements either 1, and then in B it is 6. If it is 2, this is 3. If it is 3, this is 2, and if it is 6, then this is 1. So these are the possible cases for number of elements in A and number of elements in B. Now from the other information that 2, 5 is what? That is the element of A cross B. It means what? It means 2 belongs to the set A and 5 belongs to the set B. Similarly, next element is what? 3, 7, and we know 3, 7 belongs to A cross B. So it means again 3 belongs to your set A and 7 belongs to the set B. Now the next element is 4, 7, and that belongs to A cross B. So from here you can say that 4 is the element of A and 7 is the element of B. Okay, so from here we can conclude that A contains 2, 3 and 4. Okay, maybe other elements, I don't know till now. And set B contains how many elements? Set B contains 5 and 7 till now. I don't know, maybe B contain other than that elements, these elements. Okay, so but now we have one information that number of element in A cross B is 6. So we have this case, A contain 3 elements and B contain 2 elements. Yes, so it means these are my sets, A set and B set. Now the cardinality of A cross B is what? That is 3 into 2, which is 6. So yes, this is my set A and this is my set B. So now we can conclude what? We can find A cross B, that A cross B is 2, 5. Next element is 2, 7. Next is 3, 5. 3, 7. 4, 5. And 4, 7. So these are the elements of your A cross B, and these are 6 elements. Okay, so now let's move to the next question. Next question is, prove that for any set A cross empty set is equal to empty set cross A is equal to empty set. So we'll prove this thing using the contradiction method. Let's say here we have some element. First of all, we'll prove that A cross phi is equal to phi. Okay, we have to prove this thing. So let us assume this is not an empty set. A cross phi is not an empty set. This is not an empty set. So if this is not an empty set, so it means we have some A comma B belongs to A cross phi. Yes, and it means what? It means, sir, A belongs to A and B belongs to empty set. But we know we do not have any element in my empty set. So it means we arrived at some contradiction. Okay, we arrived here. Here, this is my contradiction, that B belongs to an empty set. So it means our assumption was wrong. So from here we can say A cross empty set is what? This is an empty set. So this is the proof for this one. A cross phi is empty set. Similarly, if you take that phi cross A is not an empty set. If this is not an empty set, so we can say here we have some element such xy belongs to phi cross A. Yes, it means what? It means x belongs to empty set and y belongs to your set A. Got it? So from here again we arrived at one contradiction, that phi is an empty set. Okay, so it means our assumption was again wrong. So phi cross A is what? That is empty set. Okay, let's say this is your equation number 1 and let's say this is your second. So from these two equations you can say A cross phi is equal to phi cross A is equal to phi. So this is the proof of your question. Got it? So now let's do the next one. Next question is, Sir, relation is given like this: x comma y, where x and y are whole numbers, and x square plus y square is equal to 25. We have to find the domain and range. So domain is what? Domain is the collection of all the first elements. Yes, this one. And range is what? Range is the collection of all the second elements. This one, y. So from here, if you make a table like this, we know, sir, x, and let's say y here, and we have one information about x and y, that is x square plus y square is equal to 25. And yes, and x and y are whole numbers. They are whole numbers. Okay, they are whole numbers. So if we choose x is equal to 0, 0 is your first whole number, then y is what? When you put here, you'll get what? 0 square plus y square is equal to 25. And from here you can conclude y is equal to plus minus 5. So you can put here y is equal to plus minus 5. So if you put x is equal to 1, so then sir, we have 1 square is 1 plus y square is equal to 25. So from here we can say y square is equal to 24. So from here you can say y is equal to plus minus root 24. Okay, and root 24 can be written as 2 root 6. So this is plus minus 2 root 6. Got it? You can write this thing as 4 into 6, and root of 4 is 2. Yes, so this is 2 root 6. Got it? Next one, and here you can write your number as plus minus root 24 or 2 root 6. But we know one thing, that is what? Sir, y is what? Y is a whole number, so we cannot take these values. Okay. Similarly here, we cannot take the minus value. Okay. And if x is equal to 2, then this 2 square is 4. So 4 plus y square is equal to 25. So from here, when you conclude, y square is equal to 21. And from here you can say y is equal to plus minus root over 21. Again, sir, this is not a whole number. Okay, so no value of y. So here this is blank, blank. Okay, next, if x is equal to 3. So if this is 3, then 9 plus y square is equal to 25. So from here you can conclude y square is equal to 16, and from here you can say y is equal to plus minus 4. Again, minus 4 is not a whole number, so you have to take only one value. We have to take one value, that is y is equal to 4. Similarly, if x is equal to 4, then this is 16 plus y square is equal to 25. From here you can say y square is equal to 9, and from here y is equal to plus minus 3. So again, minus is not a whole number, so y is equal to 3. Next one, x is 5. If x is 5, then this is 25 plus y square is equal to 25. From here we can conclude that y square is equal to 0 and y is equal to 0. This is whole number, so you can take 0 here. Okay, now we cannot choose any x which is greater than 5. Why? Because x square, if you take any number which is greater than 5, then x square is what? Greater than 25. And this is what? This is non-negative quantity. So your left hand side is what? Left hand side is greater than 25. So which is not possible. Okay, so now we have to neglect minus 5 from here. Okay, minus 5 also. So we can say the values are 0 and 5. Okay, so these are the possible values of x. So all the possible values of x are known as domain. So we can say domain is what? Domain is collection of all the values of x. So you can take 0, you can take 3, 4 and 5. Yes, 0, 3, 4 and 5. Sir, why we cannot include 1 and 2? Because for 1 and 2 you do not have any y here. Okay, do not have any y. So it means they are not the part of your domain. So domain is what? 0, 3, 4 and 5. Similarly, range is what? Range is collection of all the possible values of y, and these are 5, 4, 3, 0. 5, 4, 3 and 0. Okay, so domain for this relation is 0, 3, 4, 5 and range is 0, 3, 4, 5. Both are same for particular relation. Okay, now let's move to the next one. Next question is R1 is equal to x comma y where y is equal to 2x plus 7, and we are given with that x is a real number from -5 to 5. So if x is a real number from -5 to 5, we can write like this. Okay, and we know if you multiply the inequality with the positive number, then inequality remains same. So this is -10 to 10. If we add same number on both sides, then inequality remains same. So add 7 on both the sides of your inequality, you will get this thing. Yes, and now 2x plus 7 is what? Observe this one. 2x plus 7 is y. So you can say y is from -3 to 17. Okay, this is the possible values of your y, and these are the possible values of your x. So x is what? X is all the possible values of x is known as domain. So you can say domain is what? Domain is -5 to 5 close interval. Okay, and range is what? Range is -3 to 17 close interval. So this is your final answer. Okay, now let's move to the next one. Next question is, you have to find find the domain and range of the relation defined by this. So x is what? X is 0, 1, 2, 3, 4 and 5. So x plus 2, all the possible values of x plus 2 are, x plus 2 are, so 2, if x is 0 then it's 2, then 3, 4, 5, 6 and 7. Okay, and all the possible values of x plus 3, this is 3, 4, 5, 6, 7 and 8. Okay, so this is what? This is the domain. Okay, and x plus 3 is what? That's the range for my relation. So we can say domain set is this one. This is what? This is your domain, and this one is your range. Okay, so that's your answer. Got it? Now let's move to the next one. Next is, now this is your multiple choice question. Okay, single correct. So here we have that a is equal to 2, 3. So from here we can say number of element in a is equal to 2, and we have to find the cardinality of this thing. So cardinality of a cross a cross a, this is equal to what? Cardinality of a into cardinality of a into cardinality of a, which is equal to 2 into 2 into 2, which is 8. Okay, so final answer is C. This is your correct answer. Now let's move to the next one. Next is, we are given with, if this ordered pair is equal to this one, you have to find the values of x and y. So sir, we know one thing, that if a1 comma b1 is equal to a2 comma b2, so this is true if and only if a1 is equal to a2 and b1 is equal to b2. So from here we can say x square minus 4x plus 5 is equal to x square plus 1 and x square plus 1, and y square minus 63 is equal to 1. Got it? So here you can cancel x square with x square. You can take 4x on this side, so this is 4x, and you can take 1 on the left hand side, so this is equal to 5 minus 1, 4. So x is equal to what? X is equal to 1. And from here you can say y square minus 63 is equal to 1. So from here we can say y square is equal to 64 and y is equal to plus minus 8. Okay, so possible values of your x and y are, x is 1 and y is either 8 or minus 8. So it means x is 1 or y is 8 or minus 8. So here we have only one possibility, x1 and y8. So your final answer is D. Okay, now let's do the next one. This is important question. Okay, very interesting one. So in this question we are given with, we have two sets A and B having 99 elements in common. Okay, then find the number of elements common to each of the set A cross B and B cross A. Okay, so first of all let us assume your set A is what? A is, so let's say C1 comma C2 comma C3 and C99. So these are the elements which are common in A and B. Okay, C1, C2, C3 till C99, 99 elements common in both A and B. So let's say B set is what? B set is C1, C2, C3 and so on till C99. Okay, got it? C99. But A contains maybe more than 99 elements. So let's say you have some other elements. These are A1, A2 and let's say till AN. Okay, and you have more elements in your B set. Let's say that is B1, B2 and let's say till Bm. Okay, so total number of elements in A are n plus 99 and B are m plus 99. Okay, where A and B contains 99 elements in common, C1, C2 till C99. Now we have to find common elements in A cross B and B cross A. So let's form the set A cross B. A cross B. A cross B. A cross B is what? A cross B is C1 comma C1. If you take your first element C1, then you have C1 C1, C1 C2 and so on. Then you have C1 C99. Okay, again C1 B1 and so on till C1 Bm. Yes, similarly you have this thing for C2. So sir, C2 comma C1, C2 comma C2 and so on C2 comma C99. Okay, and then you have C2 comma B1 and so on C2 comma Bm. Okay, similar things you have till C99. Okay, so you have C99 C1, C99 C2 and so on C99 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 B1 and so on C99 Bm. Okay, this is for C1, C2, C3 and till C99. After that you have A1. Okay, so you have A1 C1, A1 C2 and so on. So A1 C99, yes, and then A1 B1 and so on. A1 Bm, yes, yes. Similarly for A2, similarly for A3 and till AN. So you have this thing for AN, yes, AN C1 and so on, and this is your A cross B. Got it? Now let's draw B cross A. Draw means let's form your B cross A set. If you form your B cross A, B cross A. Okay, for the B cross A, C1 C1, C1 C2, C1 99 and then you have C1 A1, C1 A2 and C1 AN. Okay, so your B cross A is C1 C1, C1 C2, C1 C99, C1 A1, C1 A2 and C1 AN. Yes, similarly you have this thing for C2, C2 C1, C2 C2, C2 C99 and C2 A1, C2 A2 and C2 AN. Okay, we have similar things for C3 until C99, C99 C1, C99 C2 and C99 C99, and after that we have C99 A1 and so on C99 AN. Okay, so this is still C99. Now This is still C99. Now we have B1, so B1, C1 and so on. Then we have B2, then for B2 we have B1, C1 and so on until B1, A1 and AN. Yes, so this is what this is. B1, C1, B1, C2, B1, C99, B1, A1, B1, A1 and so on, B1, AN. Okay, so same thing you have for B2, for B3, similar things actually, B for B2, B3, B4 and so on until BM, BM C1 and so on, BM C99, BM A1 and so on, BM AN. Okay, so this is your B cross A set. Now when you observe both these sets, A cross B and B cross A, yes, you know that here you have A1, C1 and so on, and here you have B1, C1. So these are not equal elements. These are not the equal elements. Okay. So for the equal elements, we can observe very clearly that this portion, okay, this portion is same as this one. Yes, C1, 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 C2 till C99. Same thing. Yes, C1, 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 C2, C1, C99. Same for the C2, C1 and so on. Yes, C2, C1 and so on till C99. And then for C3 and this is still C99. After that here we have C1, B1 and here we have C1, A1. So these are not the equal elements. Okay, so we have this box. This box is equal in A cross B and B cross A. So how many elements we have now? Sir, we have 99 elements here. How many elements we have, sir? 99 elements. 1, 2, 3, 4 till 99. Again we have 99 elements here. Okay, similarly here. So how many times we have 99 elements? 99 times. Yes or no? So it means number of elements common in A cross B and B cross A are, sir, 99 plus 99 plus 99 till 99 times. Okay, 99 times. So if you take 99 common, so you can say this is 1 plus 1 plus 1 plus so on. How many times? So 99 times. So if you add 199 times, you will get what? 99 as it is into 1 into 99 times. Not 1 into 99 times. 1 plus 1 plus 1. How many times? 99 times. So this is 99. So this is equal to 99 square. This is the final answer that we have. How many elements in common? So 99 square. So your final answer is B. Got it? Now let's do the next one. That simple question. This is, so number of elements in A are 4, B are 3, A cross B cross C are 24. Find the number of element in C. So number of element in A cross B cross C is equal to 24, and this is equal to number of element in A, number of element in B into number of element in C is equal to 24. So we have number of element in A set is 4, in B set is 3. We have to find number of element in C set, which is equal to 24. Okay, so from here we can say number of element in C is what? That is 2. So your final answer is D. Got it? Now the next one is, next is 10th question. Here, let R be the relation on N where N is set of natural numbers and X is related to Y using some relation X plus 2Y is equal to 8. You have to find the domain of this set, the domain of this relation. So sir, if you again make a table here, let's say this is X, this is Y, and we know X plus 2Y is equal to what? This is 8. And X and Y are natural numbers. Yes, they are natural numbers. So let's say if y is equal to 1, if y is 1, then x is what? X plus 2 is equal to 8, so x is 6. So this is a natural number, yes, we can take. If y is equal to 2, then this is x plus 4 is equal to 8, so x is equal to what? That's 4. Okay, so we can take. If y is equal to 3, then x plus 6 is equal to 8, so x is equal to 2. So x is equal to 2. Yes, we can take x is equal to 2. Now if you take y is equal to 4, if you take y is equal to 4, so what will happen? If y is 4, then x plus 8 is equal to 8, so from here x is 0. But you cannot take x as 0 because x is not a natural number now. So now if you take any number which is greater than 4, means 5, 6, 7 and so on, value of y, then this is greater than 8. Okay, so you cannot find any natural number such that their sum will be 8. So possible values of x are 6, 4 and 2. So domain is what? Domain is 2, 4 and 6. Yes, 2, 4 and 6. So D is the correct one. Okay, now let's do the next question. Next one is, so number of relation that can be defined on the set A, comma B, comma C, comma D. Number of relation on the set A. So number of relation means, we know number of relation on set A is equal to 2 to the power number of element in set A into number of element in set A. Yes, we know that relation on A cross B. Yes, relation is from A to B actually. When you say that relation is from A to B, okay, if you write that relation is from A to B, so relation is from A to B means this is subset of A cross B, or we know that every subset of A cross B is the relation. Yes, similarly relation on set A means what? Relation is on set A means A to A. So this is what? This is subset. Subset of what? Subset of A cross A. Okay, and we know total number of subsets are 2 to the power number of element in that set. So it means every subset is a relation. So we can say number of relation equal to the number of subsets of A cross A, and number of subsets of A cross A is number of subsets of A cross A is what? 2 to the power number of element in A cross A, and number of element in A cross A is number of element in A into number of element in B. Okay, means again A. B is what here? B is A here. So this is equal to 2 to the power number of element in A is 4. So this is 4 into 4, that is 2 power 16. This is the final answer. Okay, 2 power 16, B is the correct one. Okay, got it? Now next question. Next question, that's your belongs to the basically the composition of relations. If R is relation from set A to set B, okay, how can we think about this? Sir, if you have A set and this is your B set, okay, and R is a relation from set A to set B. Let's say this is your relation from A set to B set. Now you have another relation from B to set C. So this is from B to C. Let's say this is your set C and this is some another relation S. Okay. Now you have to tell me that SOR is what? SOR is what? That's a relation from where to where. Okay, you have to basically find the domain set or the codomain, or you can say range set here. Actually that's not range, but okay. Okay, so SOR, first of all, SOR means what? SOR, if this is a relation, so for this relation you must have some input. Okay, so this SORx, this input is defined as, when you give some input to this SOR, this is defined as S of Rx. S of Rx. Okay, this is the definition. SOR of some input is defined as S of Rx. So it means here we are taking X as input of what? X is input of your relation R. So R taking input from set A. So it means SOR taking the input inputs from A. Yes, your SOR of X, I'm telling you again, SOR of X, SOR is some relation and you will give some input to it. So SOR, when you give some input, so this is defined as S of Rx. Okay, this is the definition actually. Rx means what? Rx means X is what? Input for R, and X is also the input for SOR. So it means input of SOR comes from A set. Yes, got it. Now, sir, Rx is what now? Rx is the element of your B set. Rx is what? Rx is some element of B set. Now, let's say this is some Y. If this is some Y, so this belongs to where? B set. So, S of Y is what? S of Y means what? S taking inputs from where? From B and leave it to the C. Okay, so it means this particular thing, let's say this is some Z, so this belongs to C set. Yes, so it means SOR, the output of your SOR belongs to C set. So you can say output is where? Output of SOR is output in C. So it means SOR taking element from A and leaving it into C set. So it means this is a relation from A to C. Okay, so final answer is what? A. Got it? So this is again important one. Got it? Next. Next is X is a set 1, 2, 3, 4, 5. Y is another set 1, 3, 5, 7, 9. Then which of the following is not a relation from X to Y? Relation from X to Y. So, sir, 1, 1, yes, 1 can be connected with 1. 2, 1, yes. 3, 3, yes. 4, 3, yes. 4, 3 may be the element of your some relation. That's 5, 5, yes. So it means this is a relation. This is relation. This is a relation. Okay, this is subset of X cross Y. Next one, R2, 1, 1, yes, possible. 1, 3, yes, possible. 3, 5, yes, it is possible. 3, 7, yes. 5, 7, yes. This is also the what? Subset of X cross Y. So this is also some relation. Okay. Next one. Next is R3. R3 is 1, 3. R3, 1, 3. Yes, 1, 3 belongs to your X cross Y. 2, 5, yes, belongs to X cross Y. 2, 4. 2, 4. This does not belongs to X cross Y. Yes, it means what? 2, 4. 2, 4 means 2 belongs to X and 4 belongs to Y. But 4 is not the element of your Y. So it means this is not a subset of X cross Y. This is not the relation. Okay. So you can say your final answer is C. You have to find which one is not a relation. So that is C. Okay. Now the next is next. Relation R is defined on set 1, 2, 3, 4, 5 by some condition here that mod x square minus y square less than 16 is given by what? So yes, relation R. If you observe in your relation, you can take 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Yes or no? Yes. You can take 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Why? Because if you take 1, 1, so 1 square minus 1 square is 0 and 0 is less than 16. You can take 2, 2 also. You can take 3, 3. You can take 4, 4. You can take 5, 5 also. Okay? For every element. So these are what? These are part of your relation. Yes. This all ordered pair belongs to your relation. But if you observe in first one, you have to find what relation R defined on set by this is given by. So if you take that A is your answer. So in A you do not have 2, 2. So this is not complete R. Similarly here you do not have 1, 1. So this is not the complete R. Here you do not have any 1, 1, 2, 2. So this is not the complete relation. So for these particular question your final answer is D, none of these. Okay, so you can generate your relation using this condition x square minus y square is less than 16, but here that's not our question. Question is which one is the relation R. So all of these are not belong means equals to the R. Okay, so finally here your final answer is D, none of these. Got it? Now let's do the next one. So final answer is D. Yeah. Next, this is let A is equal to this and R with a relation on A defined by A comma B. AB belongs to A and A is exactly divisible by B. Then which of the following is true? Okay. Okay then. So if A is A comma B, relation contains all the ordered pair A comma B where AB belongs to a set A and A is exactly divisible by B. So your relation is what? A is divisible by B. So if you take A as 1, so B can be 1 because we have only one factor for 1. Okay, so A is exactly divisible by B. Got it? If you take 2, if you take 2, so you can take 1. Yes, because 2 is divisible by 1. You can take 2 because 2 is divisible by 2. Yes, if you take 3, then 3 1 and 3 3. Okay, if you take 4, so you can take 4 1, 4 2 and 4 4. Okay, 4 is divisible by 1, 2 and 4. And for 6, you can take 6 1, 6 2, 6 3 and 6 6. A is divisible by B, so 1 comma 2 we cannot take. Yes, 1 is not divisible by 2, so 1 comma 1, 2 1 2 2, 3 1 3 3, 4 1 4 2 4 4 and 6 1 6 2 6 3 and 6 6. This is my relation where A is exactly divisible by B. Okay, so now we have to find the domain and range. So if you observe, domain is what? Domain is domain set is 1 2 3 4 and 6. 1 2 3 4 and 6. Okay, the complete set A 1 2 3 4 and 6. This is your domain. And range is what? Range is collection of the second elements 1 2 3 4 and 6. So 1 2 3 4 and 6. So clearly from here you can say domain is equal to what? Range. So my first option is the correct one. Domain is same as range. Okay, so A is the final answer. Next one. So this is from revision section in your assignments. First question is solve x minus 2 upon this greater than 2x minus 3 upon 4x minus 1. So how can we simplify it? First of all, take your right hand side on the left hand side and make your right hand side is equal to 0. So you can say this is x minus 2 upon x plus 2 minus 2x minus 3 divided by 4x minus 1 greater than 0. Yes. Now you can take the LCM. If you take your LCM, so you will get what? X plus 2 4x minus 1. Yes, and this is what? X minus 2 into 4x minus 1 minus 2x minus 3 into x plus 2 greater than 0. So when you simplify it, you will get what? You will get 4x square minus 8x minus x minus 9x. Yes, 4x square minus 8x minus x minus 9x plus 2 and minus, and the next thing is 2x square and 4x minus 3x, which is plus x minus 6 divided by x plus 2 4x minus 1, okay, greater than 0. So again when you simplify it, you'll get 4x square minus 2x square is 2x square, minus 9x minus x minus 10x, plus 2 and plus 6, this is plus 8, divided by x plus 2 into 4x minus 1 greater than 0. Yes, now we can divide both sides by 2. If you divide by positive number, then inequality remains same. So you can say this is x square minus 5x plus 4 divided by x plus 2, 4x minus 1 greater than 0. Now you can write the linear factor of this thing, x minus 4, x minus 1 divided by x plus 2 and 4x minus 1 greater than 0. Yes. So now we can apply what? We can use the wavy curve method. Wavy curve method is, wavy curve says draw your number line, write zeros of numerator and denominator. So 4 and 1. So let's say 1 is here, 4 is let's say here, 1 by 4, let's say 1 by 4 is here, and then you have minus 2 is here. Okay, now sorry, so this is 1 by 4. Okay, using the wavy curve method, we can say here in the rightmost we have plus, powers are odd number, so x minus 4 comes from here, power is odd number, so change the sign. Similar concept, change the sign, minus, and again change the sign. You want what? Values of x where your expression is positive. Expression is positive in the interval minus infinity to minus 2. So x belongs to minus infinity to minus 2 open, union 1 by 4 to 1, open, union 4 to infinity, open. Okay, so this is your final answer. Minus infinity to minus 2, union 1 by 4 to 1, and union 4 to infinity. Got it? So this is x for which this thing is true. Okay, so wavy curve is very important. Wavy curve method. Okay, wavy curve method. Got it? Wavy curve method is important for your inequalities. Got it? Next one. Next question is the equation involving modulus. So how can we simplify it? Solution is, so first of all draw your number line. Now write the zeros of these functions, x plus 1 and 2x minus 3. So this is at minus 1 and this is at 3 by 2. So now we have three different intervals. So in 3 by 2 to infinity, x plus 1 opens with plus sign, 2x minus 3 opens with plus sign, and this thing is 4. And in minus 1 to 3 by 2, x plus 1 opens with plus sign, and the next one open with the negative sign is equal to 4, and here both will open with the negative sign. So minus of x plus 1 minus of 2x minus 3 is equal to 4. Now simplify it. Okay, when you simplify your equations, you will get what here? This is minus x minus 1 minus 2x plus 3 is equal to 4. When you simplify, you will get minus 3x plus 2 is equal to 4. So 3x is equal to minus 2. So x is equal to minus 2 by 3. Okay, x is equal to minus 2 by 3. Yes, minus x minus 1 minus 2x plus 3. When you simplify, minus 3x plus 2 is equal to 4. So 3x and 2 minus 4 is minus 2. X is equal to minus 2 by 3. Similarly, when you simplify this one, you will get x plus 1 minus 2x plus 3 is equal to 4. So this is minus x plus 4 is equal to 4. So from here you can say x is equal to 0. Okay, and the last one is what? This is your 3x minus 2 is equal to 4. So 3x is equal to 6. So x is equal to what? X is equal to 2. Okay, now the important one. So the important one is what? Here you have x is equal to 0. Your solution is x is equal to 0 in this interval. So do we have x is equal to 0 here? Yes, we have x is equal to 0. So this is acceptable. Okay, similarly, 3 by 2 to infinity, we got x is equal to 2. So do we have x is equal to 2 here? Yes, we have 2 is here. So this is also acceptable. But what about this one? This is the solution. This is the solution here, minus infinity to minus 1, and the value is minus 2 by 3. Minus 2 by 3 is not here. Minus 2 by 3 is somewhere here. Yes, somewhere here. So it means in this interval you do not have this value. So this is not acceptable. Yes, because this is the solution in minus infinity to minus 1, and x is minus 2 by 3 is not here. So this is not your solution. So your final solutions are x is 0 and 2. So you can say x belongs to 0, 2. Okay, you have only 2 elements in your set, solution set. Okay, so this is the answer. Now let's do the next one. Next question is, two finite sets have m and n elements. Let's say you have two sets A and B. So number of element in A set is m, and let's say number of element in B set is n. Okay, two finite sets having m and n elements. Got it. The total number of subsets of the first set. So total number of subsets. So number of element in the power set is the total number of subsets. So this is equal to 2 to the power m. And similarly, number of element in the power set of B set, that is 2 to the power n. Now we are given with the total number of subsets of the first set. Total number of subsets of the first set is 48 more than the total number of subsets of the second set. So you can say 2 to the power m minus 2 to the power n is equal to 48. Yes, number of element in the number of subsets of first set is more than the number of subsets of the second set by 48. So this is 48. You have to find the value of m and n. So clearly, if you use your hit and trial method, so you can say m is equal to 6 and n is equal to 4. Yes, that's the answer. Got it? 2 power m, 2 power 6 is what? 64. Minus 2 power 4 is what? 16. This is equal to 48. Okay, so that's your answer. M is equal to 6 and n is equal to 4. This is your final answer. Now next one is, so your question is, find the number of proper subsets of this set 1, 2 and 3. Okay, so first of all, let's say this set is what? This set is one A set, that is 1, 2, 3. How many elements we have? So cardinality of this set is 3 elements we have. So cardinality of this set is 3. And total number of subsets are, total number of subsets. So total number of subsets of set A is what? That is 2 power number of element in that set, that is 3, which is equal to what? Which is 8. Got it? But we have to find the proper subsets of this set. So proper subsets are what? Total subsets, number of proper subsets are total number of subsets minus 1. That 1 is for what? The set itself. Yes, because the set itself is what? It's a subset of itself. So you can say total number of proper subsets is equal to 8 minus the set itself. So final answer is 7. Okay, so your final answer is here 7. Now let's do the next one. Next question is, a survey shows that 63% of the people watch a news channel, whereas 76% watch another channel. If X% of the people watch both the channels, then find the least values of X. So let's say this is your set A and this is your set B. Okay, set A is what? Set A is collection of people in which they watch news channel. So total X people watch both the channels. So let's say here we have X% of people, or first of all we assume that total population is what? Let's say total population is 100. If total population is 100, so X% of 100 is X. So X number of people watch both the channels. Okay, A is what? A is for the news channel. So 63% of the people watch a news channel. So here we have 63 minus X. Got it? And now 76% watch another channel. So for the another channel, let's say that set is B. So we have 76 minus X watches only another channel. Okay, so we know this is what this is. Total number of elements in A union B is n of A union B, that is equal to n of A plus n of B minus n of A intersection B. So n of A union B will be Na, number of element in set A, that is 63, plus number of element in set B, that is 76, minus number of element in A intersection B, that is x. Okay, so this is equal to 139 minus x. So number of element in A union B is 139 minus x. And we know what? We know A union B means what? Number of people watches any one of channel. Either they are watching news channel or some another channel. So we know that this n of A union B, number of people, is what? That is less than or equal to 100. Yes, because total population is 100. So number of people who watches news channel or another channel or either one of them, that is what? That is less than or equal to your total population. Yes, n of A union B is equal to less than equal to 100. So we know n of A union B is 139 minus x, which is less than equal to 100. When we simplify it, we can take x on this side and 100 on the left hand side. So this will be 139 minus 100 less than equal to what? This is x. So from here you can conclude x is greater than equal to 39. Yes, from here we can say x is greater than equal to 39. And we know if something is greater than or equal to 39, then the least value is what? Least value is 39. So that's your final answer. Okay, so this is all about your assignment number 1. Thank you everyone. Bye bye.